What's up, 8th graders? Today we're going to look at Unit 4, Lesson 2, Keeping the Equation Balanced. So let's go ahead and talk about the materials you will need for today. You'll need your student workbook, you will also need a pencil, and of course you're going to need some paper. All right? The vocabulary words to focus on today will be equations, equality, solution, variable, unknown, like terms, and distributions. So let's focus on our learning targets. Our learning targets are as follows. You're going to be able to connect the idea of balance to an equation, represent balance hangers with equations, explain the connection between the bags of corn tasks in the hanger diagram, add integers by identifying zero pairs, and use zero pairs to solve equations. All right. For our first activity, I want you to pause the video and look at these socks and tell me what do you notice and what do you wonder. When you're ready, resume. Also, you can find this in your student workbook on page 13. So make sure you write down what you notice and what you wonder and then resume the video when you're ready. Okay? Ready, set, go. All right, welcome back. So what do Mr. G notice? Well, Mr. G noticed two different pairs of socks. One is red, one is blue. I noticed that the red socks are balanced, and I noticed that the blue socks are not balanced. So what do I wonder? Well, I wonder if the blue sock has something in it on the left side. Why is it hanging lower than the right? Is it wet? Is it a ball or something in there that's holding it down? What is causing it? Was someone putting on it? I'm just trying to figure out what happened to cause the blue socks to be unlevel or unbalanced. All right, let's look at your workbook, page 14. So it says the hanger is currently balanced. So look at this hanger. You can see that it's balanced with all these shapes on both sides. Elena decided to take 2 triangles off the left side and 3 triangles off the right side. Will the hanger still be in balance, or will it tip to one side like the socks did? Which side, and explain how you know. Okay, pause the video and I want you to answer that question. When you're ready, resume and we will go from there. Ready, set, go. All right, so hopefully you had a chance to go back and look at the sock that you saw here and see how it tipped, because we know it wasn't balanced, right? And try to help you figure this out. So what we're going to do, we're going to go ahead and do what Elena did and go ahead and take 2 triangles off the left, and then we're going to take 2 triangles off the right. Okay, so, but let me backtrack just a little bit. If this is balanced, and I take 2 off the left, in order for it to remain balanced, shouldn't I only take 2 off on the right as well? I just want you to think about that for a second. But in this case, Elena took off 3. So if she took off 1 more than she took off on the left, will it be balanced? Of course not. It has to be the same thing. So what you do on one side, you must do on the other if you want to maintain balance. Okay? All right, let's check out this next part. It says the hanger is currently balanced. So look at this hanger again. If a triangle weighs 1 gram, how much does a square weigh? Pause the video and I want you to see if you can figure it out. When you're ready, resume and we will go from there. All right, so we're going to use this right now and we're going to think about the bag of coins activity that we did in our last video, right? Where we was trying to figure out how many coins were in each bag, and we had a bag of coins on one side and we had the coins on the other to try to figure out what it equal to. Well, this is going to be the same type thing that we're doing, except this time we have squares and triangles, okay? So what we're going to do is we're going to give each triangle a value of 1 because that's what it said, okay? So we're giving each triangle a value of 1. And so now you can see 3 squares plus 2 triangles is equal to 1 square plus 5 triangles, okay? And what are we going to do? We are trying to figure out how much each square is worth. So the first thing we can do is let's just go ahead and get rid of 2 triangles on the left. If we want to keep it balanced, how many triangles should we get rid of on the right to keep it balanced? You're correct. You're going to get rid of 2 on the right. Awesome job. Okay, now what is another thing that we can move from the left that we can also move from the right? But remember, we have to do the same exact thing. So what could we possibly do to keep it balanced? That's correct. You can get rid of a square on the left and a square on the right. So now our job is to figure out what's left. Well, we have 2 squares on the left and 3 triangles on the right. If I give one square to one triangle and another square to another triangle, this is what I'm going to have. I'm going to have one more triangle left over. So now what do we do, Mr. G? Well, I'm glad you asked. The next thing we need to do is give that one triangle to both of the squares. And there you have it. And so what does that mean? Well, that's going to mean that each square is worth 1.5 grams. Okay, each square weighs 1.5 grams. Good job. Okay, so now let's check out this slide. It says addition on both sides keeps them equal. So we can see that we have one triangle on the left and one triangle on the right, and 1 equals 1. Yeah, but guess what? If we add another triangle, what happens? It's still balanced because we add 1 to the left, then we turn around and add 1 to the right, and it's still balanced. And 2 equals 2. Let's do it again. Add 1 more to the left, add 1 more to the right, still balanced. 3 equals 3. Okay? But what happens if we subtract these bad boys? We're going to do the same thing. You get rid of 1 on the left, you get rid of 1 on the right, it's still balanced. Okay? 2 equals 2. Do it again. Get rid of 1 on the left, get rid of 1 on the right, it's still balanced. 1 equals 1. Awesome job. Now let's check out multiplication. So what happens if we multiply on both sides and keep them equal? As long as we multiply by the same thing, brother, we're going to be good. So multiply both sides by 2. So we have 3 equals 3, and we multiply both sides by 2. We're going to get what? 6 equals 6 on both sides. But what if we decide we want to, multiply this? I'm sorry, not multiply this. We're good on multiplication. Let's check out division. What if we decide we want to divide on both sides? So we have 12 equals 12, and we want to divide it by 3 on both sides. We're going to end up with what? What do you think we're going to end up with? You're correct. 4 equals 4. A balanced equation is what we're going to have. So remember, what you do on one side, you must do on the other side. Awesome job. Okay, so that was takeaway number 1. So legal moves to keep balance. If you add something to one side, you must add the same exact amount to the other side. If you remove something from one side, you must remove the same exact amount from the other side. These are known as properties of equality. If you multiply something to one side, you must multiply the same exact amount to the other side. If you divide by something on one side, you must divide by the same exact amount on the other side. These are known as properties of equality. Okay, let's review some work with negative numbers. Ooh, the temperature at 8 o'clock a.m. was negative 5 degrees. Oh my God, it's chilly cold. By noon, the temperature rose 5 degrees. Thankful for that. What was the temperature at noon? Whew. Okay, so this is what we're going to do. Negative 5 plus 5 degrees equals, all right? I want you to pause the video and see if you can figure this out on your own. Whether you can create you a thermometer. I want to see if you can figure out the answer to your problem. Ready, set, go. Okay, here's my thermometer. And as you can see, where are we starting again? At negative 5, right? And then by noon, the temperature is going to rise 5 degrees. So right here, I want you to see that the temperature is negative 5 degrees, which means it's 5 degrees below 0, okay? That's what that means. We are 5 degrees below 0. 1, 2, 3, 4, 5, okay? So now when we go up 5 degrees, we're going to see what the temperature is going to be, okay? Here we go. I want you to see if you can check your answer, see if you got it correct. Go up 5 degrees and see what you come up with. Ready? You can pause the video when I say go. Ready, set, go. Okay, welcome back. Let's check and see what happens. Now it's 12 o'clock and then the temperature has arisen. So here we go. Now we have green triangles going up, which means something is going up, and that's a positive situation. So what is the temperature after 12 o'clock? The temperature is now 0 degrees. Y'all, I don't know what you mean, but that's still chilly cold. All right, let's check out the next part. So let's review some work with negative numbers. The temperature at 8 o'clock a.m. was negative 5 degrees. By noon, the temperature rose 4 degrees. What was the temperature at noon? So we have negative 5 degrees plus 4 degrees. So I'm going to give you the thermometer this time, okay? And I want you to pause the video and see if you can figure out your answer. Ready, set, go. All right, welcome back. So remember, negative 5 degrees, meaning that it's 5 degrees below zero. So that's where we are, 5 degrees below zero, okay? And then at 12 o'clock, it went up 4 degrees this time, okay? So we're going to go up 4 degrees. All right. So what is our answer going to be? Well, we went up 4 degrees. We didn't quite reach zero yet. So our answer is going to be negative 1. Very good, ladies and gentlemen. All right, let's check out this one. The temperature at 8 o'clock a.m. was negative 5 degrees. By noon, the temperature rose 7 degrees. What was the temperature at noon? So we have negative 5 degrees plus 7 degrees. And we're going to figure out what our answer is going to be. So I'm going to let you pause the video right here, solve for your answer, and let us know what you got. Ready, set, go. All right, welcome back. So negative 5 is below zero. So there we are. And now we're going to rise up 7 degrees by 8 o'clock a.m. So here I am. If you want to now, if you was having trouble and you couldn't figure it out, then go ahead and pause the video. And since I already helped you out, I want you to go up 7 degrees and see what your answer is going to be. Okay? Ready, set, go. All right, welcome back. So hopefully you had a chance to figure out your answer. We go over it, and here we go. So remember, it's rising up 7 degrees. So therefore, what is the temperature outside at 8 o'clock? I'm sorry, not 8 o'clock. At noon, the temperature is going to be 2 degrees. All right. So let's review a little bit. We're going to look at some fluency stuff. So we have 6 plus 5. All right. I want you to get your pencil and paper ready so that you can go ahead and answer these questions. Let's see if you can beat Mr. G. Okay. So 6 plus 5 equals what? You're right, 11. What about negative 5 plus 4? Ha ha! Negative 1. Well, what about 5 plus a negative 4? 1. Good job. 2 plus negative 2. 0. Negative 9 plus 1. Negative 8. Ooh. But what about negative 6 plus negative 6? Negative 12. What about 5 plus a negative 6? Negative 1. What about 9 plus a negative 1? 8. What about negative 1 plus 9? 8. What about negative 3 plus a negative 3? Negative 6. What about 4 plus a negative 4? 0. What about negative 2 plus 7? 5. Awesome job. Please don't forget to like, share, and most importantly, subscribe to Basic Math Skills with Mr. G.